Scalars such as number of items, length, area, and similar quantities can be represented by a single real number. Such quantities determined solely by their magnitude are called scalars. On the contrary, quantities like force, velocity, acceleration, and similar quantities, which possess both magnitude and direction, are termed vectors. Vectors are typically depicted as arrows, where the arrow's length signifies the vector's magnitude, and its direction indicates the vector's orientation. In precalculus, two-dimensional vectors are commonly dealt with, and they are effective in describing and analyzing various physical phenomena. A vector in the plane is represented by a pair of numbers corresponding to its horizontal and vertical elements. Consider 2 points, A and B. Let's ponder the movement from point A to point B. The angle formed by the arrow and the horizontal line is denoted as theta. The horizontal and vertical differences are labeled as x2 minus x1 and y2 minus y1 respectively. They are called x component and y component. Point A is the initial point, and point B is the terminal point. The movement from point A to point B is called vector AB, defined by its x and y components. The distance between 2 points is the length of the arrow, referred to as the vector's magnitude. The angle formed between the arrow and the horizontal line is known as the direction angle, which can be calculated using the arctangent function applied to the ratio of the vertical component to the horizontal component. For instance, consider the vector AB from point A to point B. The vector is named AB, and its components are 4 and 3. Its magnitude is 5, and the direction angle is approximately 36.87 degrees. Now let's explore the opposite direction. The vector from point B to point A, denoted as BA, has components of -4 and -3, the same magnitude of 5. And a direction angle is determined as the sum of 180 degrees and the reference angle. It is approximately 216.87 degrees. Vectors AB and BA are opposite vectors, having the same magnitude but pointing in opposite directions. Considering 4 different points, A, B, P, and Q, let's examine vectors AB and PQ. The components of both vectors are 4 and 3, making them equivalent vectors, vectors with equal magnitudes and directions. Continuing with the example of vector AB from point A to point B, we can find a unit vector in the same direction. The unit vector is obtained by dividing each component of vector AB by its magnitude. Therefore, the unit vector has components 4 over 5 and 3 over 5. Now, let's address a problem. The unit vector of PQ has the components of 4 over 5 and 3 over 5. So the desired vector is obtained by multiplying this unit vector by 10, which is called scalar multiplication, resulting in components 8 and 6. Let's consider another problem. Let's denote the vector we want to find as vector u. Vector u is formed by the magnitude and the trigonometric ratios of the direction angle. Given that the y component is 5, the magnitude of vector u is 10 square root of 3 over 3. Therefore, the x component is -5 square root of 3 over 3. Hence, the vector u we are looking for is determined. See you next time.